In this video, we will learn about resolving vectors. This is part of the physics theory lessons on the Edexcel IAL Physics syllabus. Even the Cambridge students, the mathematics students can also learn about resolving vectors from this video. Okay, so this is chapter 2.1.7. Previously, we have seen the explanations to the other chapters under chapter 2 mechanics. By the end of this section, you should be able to explain that any vector can be split into two components at right angles to each other. Calculate the value of the component vectors in any such right angled pair. Resolution. So what is this? Now I have created a note here. So this is the note that I created. All these notes on the lessons are available to paid students. So this is just one lesson that I'm showing you the notes of, but we have notes for all the different lessons. The students who purchase the complete Edexcel IAL Physics course, which can be done online from any part of the world, will have access to all the notes, the theory videos, the solutions to tutorials, then solved past exam papers. The video explanations are there for every single tutorial, every single past paper, and also all the theory lessons. So this is one of the theory lessons that we are going to discuss from the complete syllabus. Okay, so here is the note. Now let's say we have this vector r that is in that direction. We want to get the components of this vector. To get the components of the vector, we have to resolve the vectors. So this is the x component because it is in the x-axis direction. We call it rx. Then this is the y component, so we call it ry. Now you can see the angle between these resolved vectors ry and rx is 90 degrees. So we have this vector and we can form a rectangle like this. When we form a rectangle like this in this direction, because we can say that is in the x-axis direction, we call it rx. The other one is in the y-axis direction, so we call it ry. Now let's say the angle here is theta. Okay, using trigonometry, we can see that rx is equal to r cosine theta, because we consider this right angle triangle. Now for trigonometry you have learned about this. So cut over, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So we have a right angle triangle here. The longest side in that right angle triangle is the hypotenuse. Then the adjacent side is the side adjacent to the angle. That's why we call it the adjacent side. The opposite side is the side opposite to this angle. Now what is sine theta? Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse, and that's what we do here. So you can see cosine theta is this side, which is rx, the adjacent, divided by the hypotenuse r. So cosine theta is rx over r. Then this side is ry. So you know, we have previously learned that a vector can be shifted from one position to the other as long as the length and the direction of the vector are the same. The length is proportional to the size of the vector. The direction is indicating the direction of the vector. So this vector here can also be drawn like that. Now then we have again this triangle. So let's say this side and this side are equal. Then we have ry divided by r, ry divided by r is equal to sine theta. So you know sine theta is opposite over hypotenuse. So opposite over hypotenuse. So we have this using trigonometry for the angle formed. That's how we get these two equations. Now you can see rx is the x component of this vector, ry is the y component of the vector. In a previous lesson, we learned about finding the resultant. So if you want to find the resultant of this force or this vector and this vector ry, remember force is a type of vector. So when we are using this theory that we learn here for vectors, it can be applied to any vector. It can be a force vector, it can be some other vector, but most of the time we are dealing with force vectors. Okay, so using the Pythagoras theorem, we can find the resultant. This is the resultant of this vector and this vector. That is what we learned previously. Now we are learning how to split this certain vector into its components. That's what we learned just now. Now anyway, previously this is what we learned using the Pythagoras theorem. R squared is equal to this side Rx squared plus this side Ry squared. Then what do we mean by resolving or resolution? Resolving vectors or resolution is the determination of a pair of vectors at right angles to each other. See, this vector and this vector are perpendicular or at 90 degrees at right angles to each other. That sums to give the single vector they were resolved from. So sum means we have to do vector addition. Okay, so we use the Pythagoras theorem. Okay, so this basically summarizes what is in this lesson. Now let's go through some examples. The component in the y direction, we can also call it the vertical component. The component in the x direction can be called the x component. Okay, so here is an example. Now you can use your calculator and find the component of this vector in this direction and that direction. And by the way, when we use the Pythagoras theorem, 12 squared plus 5 squared whole thing square root will give you 13. This is a Pythagorean triple. Remember, the 3 4 5 triangle is a Pythagorean triple. So if in a right angle triangle this side is 3, this side is 4, then the hypotenuse will be 5. That's a Pythagorean triple. Similarly, this is also a Pythagorean triple. This side is 12, this side is 5. See, this side and this side, they are equal for this triangle. Then the other side will be 13. So it's 12, 5, 13 triangle. Okay, so the original vector of 13 meters per second. Now again, you can see here the vector is the velocity. Okay, this is the velocity vector. We can resolve the components of the velocity in the horizontal direction and the vertical direction. So here the original velocity vector of 13 meters per second has been resolved into horizontal and vertical velocity vectors. Horizontal into a horizontal and a vertical velocity vector, which would separately be the same overall effect. An object moving right at 12 meters per second and up at 5 meters per second will move 13 meters each second, that is 13 meters per second, at an angle of 22.6 degrees up and right from the horizontal. So if something is moving at 13 meters per second this way, that means every second it is also, if you consider how far it moves in this direction, when it is going that way, it will move 12 meters in 1 second. This way it will move 5 meters. Okay, resolving vector calculations, so that way you can get the resultant also. 12 squared plus 5 squared equals 13 squared. Okay, then resolving vectors. Now let's say we have this vector, velocity vector 4.2 meters per second. The angle here is 40 degrees. We want to find the x component and the y component. Now here this is the angle, so then we have to consider this triangle. So if it's sweeping the angle, then it will be cosine. So 4.2 cosine 40 degrees, we are sweeping the angle, equals Vy. Okay, so in other words we can say Vy equals 4.2 cosine 40 degrees. See, Vy equals 4.2 cosine 40 degrees. Same diagram. And over here you can see that they are showing you that, see, cosine is what? Adjacent over hypotenuse. Adjacent over hypotenuse. Vy over 4.2. Then Vy equals this. So that's why when you are very familiar with it, you can simply say this side is 4.2 cosine 40. So if it sweeps the angle to go to this side, if it covers or sweeps the angle, we use cosine. If it's the other side, that is the perpendicular side to that, then we use sine. So Vx equals 4.2 sine 40 degrees. Vx equals 4.2 sine 40 degrees. Now if you are new and if you are not familiar with getting this step directly, you can again see using trigonometry the way you learned in the O-level class, sine of these angles opposite over hypotenuse. So that is what we have. Then you can get this. Now remember, always the component should be less than the actual vector if it is at an angle like this. If the angle is 0, of course, then if this angle was 0 degrees, then this vector will be this way. So the y component will be equal to that, and there won't be any x component. But if it is at an angle like that, always the components will be lesser than the actual vector, because they are components. They are found by resolving. So here you can see Vy is 3.2 meters per second. Vx is equal to 2.7 meters per second. So this I told you have learnt in the O-level class. Then we can also resolve along the plane and perpendicular to the plane. So in this case, we can take the x-axis either this way or up the plane. Then the y-axis is either down the plane or up the perpendicular to the plane, up or down. Okay. So remember, if you use the y-axis this way, you can use the x-axis that way, or even you can use this way. Then you can imagine you are seeing it from the other side. So this is the plus y direction, this is the plus x direction. Or else remember, you can tilt the axis. Now for example, if you look over here, so let's say this is the x-axis, my thumb is the y-axis, so I can move it this way. Now my thumb will be the y-axis, still vertically upwards, but my index finger is now to this side. Earlier it was to this side, now it is to this side. So you can see the y-axis direction is still the same, but the x-axis direction is so like that we can switch the axis depending on the slope. Now in this case it's something like that, right? Yeah. So we have, normally we take it this way, plus x, then y, but we can also do something like that. So this way, okay? So we can take the y-axis positive direction this way, x-axis positive direction that way, and then we can find the resultant. Now the resultant is this, and the components of that are these two. So let's see, okay, here is the example. This submarine, resolving submarine velocity can be important to avoid crashing. This angle is 45, here it's 30, this is the velocity. Okay, so here you can see velocity, we can resolve it in the velocity in the vertical direction and in the horizontal direction. Remember, we learned what that means here. If something is moving this way, that means it's moving how much distance it covers horizontally per second is 12. If it's moving at an angle of 22.6 degrees at a speed of 30 meters per second from the horizontal, measuring the angle from the horizontal, okay, then it will move vertically 5 meters per second. Similarly, if the velocity of the submarine is this way at an angle 45 degrees, then in this direction it will be v cosine 45 degrees. This way it will be v sine 45 degrees. So vertical component, horizontal component. Submarine velocity resolved into horizontal and vertical components. Okay. However, the submarine commander is likely to be most interested in knowing how quickly his vessel is approaching the seabed. This could be found by resolving the velocity of the submarine into a component parallel with the seabed, see, along the seabed or parallel to the seabed, and the right angled pair that will be a component perpendicular to the seabed. So I told you, it will be resolved parallel to the plane, or also called along the plane, and perpendicular to the plane. It is this, so V perpendicular, that will tell the submarine commander how quickly he is approaching the seabed. Because if he is moving at an angle like this, how quickly he is approaching the seabed will be the component of the velocity V in that direction. So we can find it. So this will be V sine 15 degrees. This angle is 15, so we consider this right angle triangle here, the 90-degree angle, V sine 15. This way it will be V cosine 15 degrees. Okay, so that's the end of that lesson. Now you can practice more questions. You can do the tutorials and practice more questions. First you can do the questions here, so that it will ensure you understood the theory that was taught here. And yeah, so after you finish all these questions here, then you can start the tutorial questions and do them, then watch the video explanations for the tutorials, and if there are any questions we can discuss them in the online class. Okay, so the next topic is this, and this video I think I have already uploaded.